Hello, Algebra. All right, so this video is for 3-3. So if you noticed, I don't know if you noticed for yesterday, that standard for 3-1, it was standard F. We're going back a standard and going to look at standard E. There is no standard D. I know it's weird, but we're going to be looking at standard E now. So that's the next one we'll end up assessing on. But we had to talk about 3-1 and get to that standard so that 3-3 would end up making a little bit more sense. Okay? So to start, we are looking at rate of change and slope. So what in the world is rate of change? So rate of change is a ratio that describes, on average, here, what if I just, that's not gonna work, never mind. Sorry, I was gonna pause it and then write it all and then have it written for you. Okay, so rate of change is the ratio that describes, on average, how much one quantity changes with respect to another quantity. So, for example, if your miles from home will change with respect to, I guess that's not a very good example. So let's see, the number of gallons of gas you can put in your car, the price of your gas will vary depending on how many gallons you're putting in, right? One depends on the other. They'll vary at the same time, okay? So here's another way of talking about it in respect with x's and y's. Okay, so just like yesterday we were talking about linear functions with x's and y's, now we're going to look at x's and y's in this sense. So if the quantities are x, and so x is the independent variable. We always say x is independent. I am like struggling and I might have just spelled that wrong and I'm sorry. The quantities are x, and x is our independent variable, and y being dependent, meaning the value of y will depend on the value of x. Then the rate of change is, all right, so just a little side note here before I move on to that. This triangle, this is a Greek letter, and I mean it's delta, okay? Delta means change, right? So this triangle means change, okay? You're going to need that in math for probably the rest of your life. Right, so the rate of change is the change in y over the change in x, that ratio. Change in y to change in x. All right, that was a long definition and kind of confusing. So let's just look at it in an example. It says find rate of change. So we're going to use the table to find the rate of change and then explain its meaning. So, excuse me, what we're going to do is we're going to find the rate of change through rows, okay? So this row, with this x value, we get this y value. For this row, for this x value, we get this y value. This row, this x value, we get this y value. So what we're going to do is we're going to look at the change between rows. So if we look at these two rows, all right, and we just look at the change in x, okay? We go from, what is our change? Well, to get from 2 to 4, we add 2. So our change is 2. So the change in x is 2. All right, now let's look at y. How do we get from 78 to 156? Right, you can do it in your calculator, 156 minus 78, but you'll get 78. So the change in y is 78. We have to add 78 to get to 156. So I'm also going to write these down kind of in between. So plus 2 plus 78. All right, now let's look at these two. So if we look at the x again, to get from 4 to 6, we add 2. So our change in x is 2. For y, to get from 156 to 234, right, you can put in your calculator, but you'll see that we add 78 again. So the change in y again is 78. So our rate of change is our change in y over our change in x. Notice we have it the same for both of these. So that's good. That means our rate of change is constant. On average, it's going to be true, and that's so far what it is here, right? So far they are all the rate of change. Let's see, so it's change of y over change in x. Our change in y for both of these was 78, and our change in x was both 72, not 72, 2. Right, so if we look at this ratio, this is our rate of change, right? And we could put our units on there as well. So our units for y is dollars, so I'm just going to write dollars. And for x, it's number of computer games. So I'll write number of games. So the meaning of this is that as the number of computer games goes up by 2, the total cost goes up by $78, right? So if I put 2 more computer games in my cart, I'm adding $78 to my cart. Now, 78 over 2, that's a ratio that we can reduce. They're both even, so if we divide 2 by 2, we get 1, and if we divide 78 by 2, we get 39, right? So that would be also the rate of change, just simplified. So same units, number of games, and dollars. So that means every time you add 1 game to your cart, you're adding $39 to your final cost. So that's what rate of change is. If we were to look at rate of change between these 2 rows and didn't consider this row here, okay, I encourage you to see what that would be on your own and then reduce it. You'll get $39 to 1 game, right? So this statement right here, we need to fill in this blank. If the rate of change is, if the rate of change is constant, so that means that between each row, it's the same thing, and it is, right? 78 over 2, right? Change in y over change in x, that's 78 over 2. Change in y over change in x, 78 over 2. If it is constant, so between each row it is the same, then we have a linear function. Okay, and we had talked about linear functions or linear equations yesterday. If you remember the standard form for a linear equation, it is ax plus by equals c. All right, so the x, there's an x and there's a y. Okay, we have a constant, and then the exponents on the x and the y are both 1, right? If there's no exponents shown, that means there's an exponent of 1, right? The reason we started talking about rate of change is that rate of change might be something you have heard of before, but it all relates to this huge algebraic concept of slope. You may have heard of slope before, okay? But I put rate of change next to it because the definitions are super similar. So slope, that is the ratio of the change in the y coordinates All right, and then this is a term that we use in math for y-coordinates or shifting in the y-coordinates. Okay, we already talked about change in y being written like that. We also call that the rise. And so the rise, it's listed over here. Rise can go up and down. All right, so on this one, our rise is down. We shift down. On this one, our rise is up. All right, and we'll talk a little bit more about how we know that. But just know that rise doesn't necessarily mean up. It just means whether you're shifting up or down. So the ratio of the change in the y-coordinates, or our rise, to the change in the, can you guess? In the x-coordinates. And there's the change in x, so we write like this, delta x, or run. All right, so run, we always just move to the right with that. If some people like to do negative run, but that's adding in a negative number, which can get kind of confusing. So we can talk about that a little bit more in class later on, but for now, just think about moving to the right? We always run forward, and to the right in math is technically forward. All right, so the slope is the ratio of the change in the y-coordinates to the change in the x-coordinates as you move from one to another. All right, so what slope does, all right, I'm going to write it right up here. It describes how steep a line is. So the value of your slope, so slope will end up being a number, right? It's a ratio. It'll tell you how steep your line is. So as you get farther from zero, whether in the positive or negative direction, your slope will get steeper. As you get closer to zero, so even if you start getting into fractional slopes or decimal slopes, your line will get less steep and come closer to being a flat line. All right. One quick thing before we jump into some examples. Hope this shows up. We use the letter M to represent slope, and that will really come in handy when we talk about different forms of linear functions and equations. M is going to start popping up. All right. So let's talk about finding the slope of a line on a graph. So this first example, we need to find the slope from a graph. And so this is our graph here. All right, we could totally disregard these points that they gave us, and we can just count our rise and our run. So yes, slope is rise over run, or change in y over change in x. So what we do is we start at our leftmost point to find our change in y and our change in x. Change in x will be our horizontal movement. Change in y is our vertical movement. So from a graph, we're going to say m is our change in y over our change in x. Okay. We start at the leftmost. It looks like we have our change in x coming first. How many units are we moving? It's 1, 2, 3, 4, 5. So our change in x is 5. And then we look at our y. It is 1, 2, 3, 4, 5, 6, 7. But are we going in the positive or negative direction? We're going down. So it's a negative 7. So that means our slope is negative 7 over 5. And you can write that as a decimal if you need to as well, but this is totally acceptable, and this is probably the easiest way to write it. So that's our slope. That's all we're really finding. So from a graph, it's just counting spaces and knowing which one to start at. All right. If we look at this situation though, where we have 2 points and we don't have a graph, can't necessarily count. All right. So when we are finding our slope, okay, we're given 2 points. Okay, we can label these 2 points as x sub 1, y sub 1, meaning our first point, and then x sub 2, y sub 2. So when I say sub, it means I'm putting a subscript, or it's the opposite of an exponent. I'm putting just a little number below the original number, just showing that these two, this x and this y, belong to my first point, this x and this y belong to my second point. All right, so if I'm given these 2 points, my slope is the change in y, so the difference between y2 and y1, so y2 minus y1, over the change in x, so the difference between x2 and x sub 1. You can always decide to flip the order to avoid negatives if you want, so do y1 minus y2, but that means you have to do x1 minus x2, okay? So if you are looking at your slope, your x2 and y2 should line up, and your x1 and y1 should line up as well. So here are our 2 points for this one. So let's find our slope. It's change in y over change in x. Let's find our change in y. So our y values are the second values, right? If we have a point, it's x, y. All right, so let's do y2. So y sub 2, so the y of the second point, so 2 minus the y value in the first point, which is negative 1. All right, and then let's do the x value for the second point, right? We have to line these up minus the x value of our first point. Sorry, I didn't realize that it slid so much. And now we simplify this. All right, so 2 minus negative 1, that's the same as 2 plus 1. 3 minus negative 2, that's the same as 3 plus 2. 2 plus 1 is 3, 3 plus 2 is 5. So m equals 3 over 5. And that would be the slope between these 2 points, the line that goes through these 2 points. Not too bad, I don't think. So on the back of your notes here, if you use the guided notes, there is this little graph and says the adventures of Slope Dude. So I'm going to show you like the cheesiest thing ever. And honestly, it's helped so many people. So let's just watch, hopefully.
Welcome to the adventure of Slope Dude. Meet Slope Dude. He loves to ski. We are going to follow him, and he'll teach us some important aspects of slope. This is the course he's skiing today. Again, what he says will teach us about slope. You need to remember that Slope Dude always skis toward the right or eastward. When he starts out, he's going uphill. It's hard work. He says puff, puff, positive as he goes up the mountainside. Puff, puff, positive, puff, puff, positive, puff, puff, positive. Now he's at the top. It was puff, puff, positive all the way up the mountain. But now he can look forward to the downhill. On the way down the mountain, he says, nice, negative, nice, negative. And now, after the downhill, he's in for the hardest part of the ski run, the long, flat part. He says, this is zero fun. This is zero fun. This is zero fun. This is zero fun. And as he finishes the flat part, he doesn't see well ahead, and all of a sudden, he comes to the edge of a cliff. It's straight down. So frightened is he that he says the worst curse word possible in math and in algebra. Undefined! This has been the Adventure of Slope.
Okay, I know that was super cheesy, but let's get the doc cam back up. So what that is telling you is what the shape of positive, negative, and zero slopes are and undefined slopes. So those are the 4 kinds of slopes we can have, and I labeled my little thing here. So going uphill is puff, puff, positive. So if we start low left and go up right, that is a positive slope. If we start up left and go down to the right, that is a negative slope. If it's just flat across, we say that that is a zero slope. So m equals 0. If the slope is straight up and down, so perfectly straight up and down, we say that that slope is undefined. Okay? So that'll come in handy. We'll definitely talk about this more in class. I will link that video in Schoology along with a really tacky but really helpful video to remind you of how to find slope. And the video name is called Slope Rider, and you'll see why it is called Slope Rider. Alright guys, that is, I know it was kind of long, but this is an important concept. So I'm going to leave it there. Make sure you email me with any questions. I can take videos, make small videos to help you guys. And yeah, I'm just here to help. So let me know if you have any questions.